every 5 or 6 or 7 years, a console arrives with substantially new capabilities. There's a lot of learning by the game developers, hopefully not too overwhelming, and soon there's games that could never have been created before. Now, it used to be that as a console designer, you'd somehow intuit what would be the best set of capabilities for the new console, and then build it in complete secrecy. For the PlayStation consoles, that period lasted through PlayStation 3, a powerful and groundbreaking console, but also one that caused quite a lot of heartache, as it was initially difficult to develop games for. So, starting with PlayStation 4, we've taken a different approach, roughly centered around 3 principles. The first of these is listening to the developers, which is to say that a lot of what we put into a console derives directly from the needs and aspirations of the game creators. We definitely do have some ideas of our own, but at the core of our philosophy for designing consoles is that game players are here for the fantastic games, which is to say that game creators matter. Anything we can do to make life easier for the game creators or help them realize their dreams, we will do. So, about once every 2 years, I take a tour of the industry. I go to the various developers and publishers, sit down, and discuss how they're doing with the current consoles and what they'd like to see in future consoles. This requires weeks on the road, as reaching the bulk of the game creators involves talking to well over 100 people at something like 24 publishers and developers. And it is incredibly valuable. By the way, the feature most requested by the developers, that was an SSD, which we were very happy to put in the hardware, but a lot of problem solving was required. I'll be doing a deep dive on the SSD and surrounding systems later on in this talk. It's also key to make a generational leap while keeping the console sufficiently familiar to game developers. I think about this in terms of balancing evolution and revolution. Now, with PlayStation 1, 2, and 3, the target was a revolution each time with a brand new feature set. That was great in many ways, but time for the developers to get up and running got longer with each console. In the past, I've called this time to triangle. Here's what I had for those 3 consoles. To be clear, I'm not talking about time to make a game. Developers will be ambitious, and it may take them 6 years or so to realize their vision. What I'm talking about is that dead time before graphics and other aspects of game development are up and running, and trying to minimize that. On the other hand, if we're trying to reduce that dead time to 0, that means the hardware architecture can't change at all. We're handcuffed. We need to judge for each feature what value it adds and whether it's worth the increase in developer time needed to support it. So with PlayStation 4, we were able to strike a pretty good balance between performance and familiarity. We got required learning back to PlayStation 1 levels. With PS5, the GPU was definitely the area we felt the most tension between adding new features and keeping a familiar programming model. Ultimately, I think we've ended up with something under a month of getting up to speed. That feels like we're striking about the right balance. I'll go into a bit more detail later today about our philosophy with the GPU and the specific feature set that resulted from it. It's also very important for us, as the hardware team, to find new dreams, by which I mean something other than CPU performance, GPU performance, and the amount of RAM. The increase in graphics performance over the past 2 decades has been astonishing, but there are other areas in which we can innovate and provide significant value to the game creators, and through them, the players. That's why the SSD was very much on our list of directions to explore, regardless of what came out of the conversations with game developers and publishers. The biggest feature in this category is the custom engine for audio. That's today's final topic. The push for vastly improved audio, and in particular 3D audio, isn't something that came out of the developer meetings. It's much more the case that we had a dream of what might be possible 5 years from now, and then worked out a number of steps we could take to set us on that path. So here again are the 3 principles, the first being enabling the desires of developers to drive the hardware design. To me, the SSD really is the key to the next generation. It's a game changer. And it was the #1 ask from developers for PlayStation 5. As in, we know it's probably impossible, but can you put an SSD in it? That was a discussion we were also having internally. It was clear that the presence of a hard drive in every PlayStation 4 was having a positive impact. A lot of things that would simply have been impossible at Blu-ray disc speeds were now possible. At the same time, though, in 2015 and 2016, when we were having these conversations, developers were already banging up against the limits of the hard drive, and a lot of developer time was being spent designing around slow load speeds. I want to focus in on just one number here, which is how long it takes to load a gigabyte of data from a hard drive. The difficulty being that hard drives are neither particularly fast nor flexible. If all your data is in one block, which is frankly not very likely, you can load 50 to 100 megabytes a second, depending on where the data is located on the hard drive. Let's assume it's on the outer edge, which means loading a gigabyte takes 10 seconds. If you compress your game packages, you can fit more data on the Blu-ray disc and also effectively boost your hard drive read speed by the compression ratio. We support zlib decompression on PlayStation 4 that gets you something like 50% more data on the disk and 50% higher effective read speed. Unfortunately, though, it's highly likely that your data is scattered around in various files on the hard drive, as well as sourced from multiple locations within those files. So lots of seeks are needed at 2 to 50-ish milliseconds each. My rule of thumb is that the hard drive is spending 2/3 of its time seeking and only 1/3 of its time actually loading data. Putting all of that together, a gigabyte is very roughly 20 seconds to load from a hard drive.